This is a demo showing how to use FaceTime with Zoom to bring your class online in a way that students can see you writing on paper. So let me start by launching my Zoom session. So I go to brandeis.zoom.us, click on Login. I will do it on the faculty online teaching session. And it's starting up. Open the app. So this should all be very familiar once you do it a few times. Join with computer audio. Hi. Right, I'm in my kitchen. I would normally not do it in the kitchen for a real class. So here I have my iPhone. And what I'm going to do is open up FaceTime and then call my iPhone and FaceTime with my iPhone. And I'll use its camera to watch me draw. So let me share the screen. And so you'll see how I do that. Share the screen. Okay, so here I'm sharing the screen, and now I will open up FaceTime. FaceTime. And where did it go? There it is. Come on. FaceTime. And I'll type in my name, Tim Hickey. And it's this is, let's see, where's my phone number? This one, and I will call. Okay, so I'm calling, and I have it right here. I'm going to answer. Okay, now I have to turn the sound off, so I have to mute it. Okay, mute is on, and I'm going to flip my phone. So there it is. I'm holding the phone. It's now looking at my keyboard. And now over here, I've got a clear box, but any box would do. I'm going to set it on the box with just the camera hanging over. About onto that. There. And now I can, let's see, make this full screen. And I can start drawing on here. Actually, I have to make it bigger, so I'm sorry. I have to turn it sideways so it flips. Good. Now put it down. And now I can draw. So start here, and let's say we want to, I have to turn the sound off too, sorry. Turn my sound way down on the phone. Great. So I might be trying to show how to calculate the area underneath the Gaussian function. Right. So this is this bell curve. And we want to find the area underneath. So we'll call that S. And the very clever trick is you do S squared is that integral e to the minus infinity of e to the minus x squared dx times the integral minus infinity to infinity e to the minus y squared dy, because it's just a dummy variable. And if we bring those products inside, it's e to the minus x squared plus y squared dx dy. So if we change coordinates, so we're using polar coordinates, so r squared is x squared plus y squared, this becomes, this is minus infinity to infinity, minus infinity to infinity. This becomes the integral from 0 to 2 pi of the integral from 0 to infinity e to the minus r squared, and dx dy is equal to r dr d theta. So this would be r dr d theta. Yep. And now if we do the substitution, s equals r squared. And also, well, first we can pull the d theta out because there's no theta in there. So that's integral from 0 to 2 pi of d theta times the integral from 0 to infinity of e to the minus s. Let's see, ds is 2r dr. So e to the minus s times 1/2 ds. So this is 2 pi. And this is the integral, this would be, the integral is minus 1/2 e to the minus s from infinity to 0. So this is 2 pi times 0 minus minus a half. Oops. So that's going to be 2 pi times a half, which is pi. Oops. Sorry. So that shows us that s squared is equal to pi. So s is square root of pi. So the integral from minus infinity to infinity of e to the minus x squared dx is equal to square root of pi. Or we usually write that as 1 over square root of pi e from minus infinity to infinity e to the minus x squared dx equals 1. Okay, so that's it. Now stop the share and go back. And so what I demonstrated was that you could write, and I think I have some problem with the volume, so I'll have to play with this. I still hear some volume on this, and I thought I had muted it. Mute? Nope, I did, it's muted. I'm not sure. I'll try to figure it out later. Okay, so that's the end, and I hope this is helpful.